So welcome to all of you. So today we will see the last chapter of this algebra. So that is what the chapter 4, complex numbers. So this is the last chapter of the paper first of the semester, first complex number. So now you are familiar with the complex number. Okay. So now we can find the root of the 4 as a plus or minus 2. Right? Because what? So that means what? 2 square is 4, minus 2 square is also 4. But what happened? We have this minus 4 then. What? So what are the roots of the minus 4? So is it plus or minus 2? So this is not plus or minus 2 because the square of every number is a positive. Square of every real number is a positive. That means here what? The root of minus 4 does not exist. That means it is not a real number. So for that, to find the root of such numbers is nothing but a complex number. So what we will do? We will take root of minus 1 as I now. It's I. Root of minus 1 is I. And what is the I square then? I square is what? Root of minus 1 into root of minus 1. So this is what? Minus 1 into minus 1. So that is root of 1. So it may be plus or minus 1 then. But now here I is what? Root minus 1. So I square is plus or minus 1. If it is not 1, then it is minus 1. If it is not minus 1, then it is 1. So I square, we have to take minus 1. If you take I square is 1, then I will not be, then the value of I will be plus or minus 1 again. Because what? I square is 1, then I is nothing but plus or minus root 1. Okay. So that is plus or minus 1 then. So it is not true. Okay. So that means what? I square must be minus 1. So I square is minus 1. I square is minus 1. Now see, if you multiply by I, so then this will be I cube. This is minus 1. This is minus I. I cube is minus I. Again, if you multiply by I, then this is what? I to the power 4 is nothing but minus I square. But I square is minus 1. Minus become plus. Okay. So again, if you multiply by I, then what we get? I to the power 5 is I. If you multiply by I, then this is I to the power 6. This is minus I. This is I square, and I square is same as what? Minus 1. I square is same as minus 1. Again, if you multiply by I, then this is I to the power 7, and this will what? I cube. This may be I cube. So this is what? Then minus I now. This is what? Minus I. If you multiply by I on both sides, so I to the power 7 is minus I. Again, if you multiply by I, this will be what? I to the power 8, and this is minus I square, and I square is minus 1, so this become 1. Right? That means if you take any power of I, it will be what? Either 1, or minus 1, or minus I, or I. That means what? If you take any integral power of I, so then we get only this is what? Plus or minus 1, plus or minus 1, or plus or minus I. That means I to the power m belongs to this set now. Belongs to this. Because m is the integer. So for negative, what I have to do? 1 upon I suppose we have. 1 upon I suppose we have. I will multiply by I on both sides. Multiply and divide by I now. So this will be what? Then I square. So I square is minus 1. So this is what? Minus I. So 1 upon I is minus I. That means if it is negative power, that means what? I to the power 36. If you want to find I to the power minus 37, suppose. I to the power minus 37. So this will what then? 1 upon I to the power 37. Right? So I to the power 37 is nothing but 1 upon. So what here now? How to find I to the power 37 now? So we cannot multiply by this up to the power 37. So what to do? So now see here, I to the power 4 is 1. I to the power 8 is 1. So that means this 4, 8 are the multiple of 4. They are the multiple of 4. That means if I to the power 4n, I to the power 4n is always 1. That means I to the power any power of multiple of 4 is always 1. And what happens this for other one? Now see, this is I cube. I cube. So that means if 3 is divided by 4, the remainder is 3. So remainder is 3, then I cube is what? Minus 1. That means when you divide by 4, then the possibilities of the remainder is what? 0, 1, 2 and 3 only. right? So that means what, if I have I to the power m, so I will divide by m, I will divide to m by 4, then I can express this is what, 4n plus r now, when n is the quotient, when m is divided by 4. Now possibilities of the remainder is what, this is what, I to the power 0, I to the power 1, I to the power 2, I to the power 3. Okay? So I to the power 0 is 1, I to the power 1 is I square is minus 1, I cube is minus I. Right? So that means I to the power m. So that means what? It is find the remainder when that power is divided by 4. So that means what here? If 37 is divided by 4, then the remainder is 1. Because what? 9 4 is 36. So remainder is 1. So that means what? What is the remainder? So I to the power 1 now here. And 1 upon I is what? Minus I. Minus I. That means I to the power minus 37 is 7 minus I. So that means what? If m is an integer, so simply so that means what? I to the power m is equal to I to the power 4n plus r, right? So this is belongs to 1 minus 1 I minus I, right? So it is remainder, remember this. So for this you have to remember that I square is minus 1, I cube is minus I cube is minus I, right? And for other you don't have problem, right? For other you don't have problem. Okay, so that means what, if you want to find the power of I, then what, divide that power by 4, just find the remainder. So remainder will be what, either 0 or 1 or remainder is what, 0 1 2 3. So if I to the power 0 is 1, I to the power 1 will be I square is minus 1 and I cube is minus I. Okay, so I hope that you can you understand this, how to find the power of m now. That means what, for exercise, do the power of this is what, 5. I to the power 22,375. So what you have to do, just divide by this, by 4. Divide this number by 4 and just find the remainder. So this remainder is what, remainder, this may be what, maybe 0 or 1 or 2 or 3. One of this. That will be the power. It is very easy, you can find this. If it is minus 1, just shift this at the denominator. Find this, what, you will get this is 1 upon then, right? And you know the value of 1 upon I is minus I. Value of 1 upon I is minus I. Okay, remember that also, 1 upon I is minus I. Okay, so now we'll define a complex number now. Definition of a complex number. Definition, complex number. Complex number. Okay, a number of the form z is equal to x plus iy, xy belong to r, I is equal to minus root of minus 1, is called complex number. Is called complex number. Very simple definition. A number of the form x plus iy, right? Where x and both x and y are real number. Okay, so and value of I root minus 1 is called, note that I square is minus 1. Okay, so that is obvious now, I square is minus 1. Okay, so now if z is equal to x plus iy, z, instead of x plus iy I can say z is the complex number. So if you say the z is complex number, then it is of the form x plus iy, is already in there. Is a complex number, is a complex number. So we are saying that this is complex number. That means x and y are real number and value of I is minus 1, because in the definition x and y are real number and there. Okay, so x is called, so x, that means what, not a coefficient of y, is called real part of z, because it is denoted by denoted by real part of Z. Real part of, this is read as a real part of Z. This is real. Okay. Y is called imaginary part of Z. It is denoted by imaginary part of Z. Right? Note 1. If real part of Z, if Z is equal to x plus iy, is a complex number, and real part of Z is equal to 0, then Z is called, so now real part of Z, that means x is 0, then Z is equal to what? Iy. Z will be what? Iy. Z is called purely imaginary number. That means your x is 0, then it is purely imaginary number. And if imaginary part of Z is equal to 0, then Z is called, that means imaginary part is 0 means y is 0, then Z is called purely real number. That means what? So we'll see some example. So suppose this is what then, so Z is equal to 2. So plus 0 I now. This I can write, this is what? 2, Z is equal to 2 is equal to, I can write 2 as ax plus iy form. That means 2 is a complex number. Because 2 I can write in the form a plus ib, or that means x plus iy. Okay. So your x is 2 and y is 0. Okay. So now here see that your imaginary part is 0. So that means what? Your Z is equal to 2 is a purely real number. Right? It is a complex number. It is called purely real number. So if suppose Z is equal to 3i, suppose this Z is equal to 3i, I can write this is what? 0 plus 3i. So I can write this is of the form x plus iy, x plus yi, or iy, doesn't matter this. Okay. So that means what? It is a complex number. And see, the real part is 0. So that means this is a purely imaginary number. So Z is equal to 3i is a purely imaginary number. Okay. So you are familiar with this one. So now suppose Z is equal to x plus iy. So we can write this of the form x, y. That means what? So this is suppose this is your x axis, this is your y axis, this is origin. Then I can write this is what? Suppose this is your x, and suppose this is your y. Then this is what? xy. I can write this complex number as x plus iy. Okay. So I can write on the plane now. Okay. So this is the order pair. So order pair in the table complex number. We can write in the form R. So that means what here? Okay. This, okay. The set of all complex numbers is denoted by this. Okay. So note that the set of real number is the subset of the complex number. So the complex number is the superset now. Complex number, because what? All the real numbers are the complex number. Because what? If imaginary part is 0, then it is called purely real number. So So that means all real numbers are complex number. That means every number is a complex number. So first we have seen the set of the natural number. So we know that all natural numbers are the real number. So that means what, all the natural numbers are the complex number. Next we added 0 in the set of the natural numbers. So the set form we call this as what, the set of the whole number. So we know that all whole numbers are the real number. So that means what, all whole numbers are the complex number. Okay. So then next we have seen the set of the integers, right? So all integers are real number. We know that all integers, because what, on the real line we can write all the integers. That means all integers are the real number. That means all integers are the complex number. Okay. So now next we have seen the rational number, a number which can be expressed in the form p by q, where both p and q are integers and q not equal to 0, is called rational number. So that also we have seen all rational numbers are real number. So that means what, here all rational numbers are real number. So that means all the rational numbers are the complex number. So we know that rational as well as irrational numbers is nothing but a set of the real number. That means irrational numbers are also complex number, and all real numbers are the complex number. So that means what, here the complex number is a superset of natural number, whole number, integers, rational number, irrational number, and the real number also. Okay. So we can draw the complex number on the, this is what, this is R2, this is called R2. That means what, plane now, R cross R now here. Okay. So this plane is called R2 and this is plane as called a complex plane. This is the complex plane. Okay. So complex number is shown on the plane now, right? So that means I can write the set of the complex number is like this, xy. So xy belong to R. This is also we can write. Okay, we can write this is the set of the complex number is like this. Okay, or you may write this what, set of the complex number x plus iy, such that xy belong to R. Okay, the set of all complex number of the form x plus iy. So x and y are real number. This is nothing but the set of all complex numbers. Okay, we can denote like this. Now suppose we have the two complex number, z1 is equal to x1 plus iy1, z2 is equal to x2 plus iy2. Okay, so z1 is equal to z2, z1 is equal to z2, imply that okay? Real part of z1 is equal to real part of z2, and imaginary part of z1 is same as imaginary part of z2. So two complex numbers are same if and only if the real parts are same and imaginary parts are same. Okay, so z1 is equal to 0, so this is 0 plus I0. Z is equal to, that means what, here I0. Okay, so that is 0 I, you can write. Okay, so that means if a complex number is 0, then the both real part and imaginary part are 0. So from that also we can prove this is what, x1 plus iy1 is equal to x2 plus iy2. I will shift this complex number to this side. So what do we get? x1 minus x2 plus I, y1 minus y2 is equal to 0. Now this complex number is a 0. So that means what? Both the real parts are 0 and imaginary part of 0. So x1 minus x2 is equal to 0. y1 minus y2 is equal to 0. That means what, here x1 is same as x2, y1 is same as y2. So that is same as what? Real part of z1 is same as real part of z2, and imaginary part of z1 is same as imaginary part of z2. Now we'll see how to take the addition of the two complex number, how to take the addition, how to take the multiplication of and the subtraction now. So z1 plus z2, how we can write z1 plus z2? So your z1 is what? x1 plus iy1, x2 is same as y2, z2 is same as x2 plus iy2, x2 plus i2. So z1 plus z2 is equal to what? So x1 plus iy1, x2 plus iy2. I can shift this is what? I can write this is x1 plus x2 plus I times y1 plus y2. That means what, you have to take the addition of the real part. and you have to take the addition of the imaginary part. Okay, so addition of the imaginary part is the imaginary part, addition of the real part is the real part of complex number. So if you want to do the subtraction, then this is also same. What? x1 minus x2, real part of z1 minus real part of z2 plus imaginary part of z1 minus imaginary part of z2. So that means what? y1 minus y2. Very simple now. So if you want to take the multiplication now, z1 into z2. So this is x1 plus iy1, x2 plus iy2. So this is what then we can multiply this like this. So as our usual, plus iy2, iy1, x2 plus iy2. So do the multiplication as usual now. Is what? x1 x2 plus I x1 y2 plus I x2 y1. I can write this. We may write y1 x2, doesn't matter this. This is I into I is I square, y1 y2. I square is minus 1. So this is minus y1 y2. So don't forget to write the minus sign here. So take the care, when it is minus then this may be plus now. Okay. So now collect the real part, x1 x2 minus, this is minus, okay, minus y1 y2 plus I times x1 y2 plus x2 y1. Okay, in this way you can do the product. In this way you can do the product. Okay, so the division that we will see later on. So first, okay, no problem, for we will take the division also. So before division we'll see what do we mean by complex conjugate. Conjugate of a complex number. Okay, so definition, let z is equal to x plus iy be a complex number. Be a complex number. Then z bar is equal to x minus iy. Then a complex number will add. Then a complex number x minus iy is called a complex conjugate. Is called a conjugate of a complex number z. It is denoted by z bar. It is denoted by z bar. Thus z is equal to x plus iy. Then z bar is equal to x minus iy. Replace i by minus I. We get a complex conjugate. Now if you want to take the division now, z1 upon z2, then this is what? X plus iy, x plus iy1, x plus iy2. So what you have to do? You have to divide and multiply by complex conjugate of the denominator. So that means what? This is what? x2 minus iy2 upon x2 minus iy2. Okay. So now we will take the product of this one. This is what? I will take the product. This is what? x1 x2 minus I x1 y2 plus I x2 y1. Now the product is, this is minus I square y1 y2 minus I, this product, minus I square y1 y2. But I square is minus 1, so minus become plus. Now this become plus. You have to take the care of this sign now here. Okay, I square is minus 1, no problem for, but there is already minus sign, so minus become plus. So y1 y2. Now this is of the form a plus b, a minus b. So we know that a plus b to a minus b is the square of the first one minus the square of the second. So this is what? x2 square minus I square y2 square. Okay, so we'll collect the real part, we'll collect the imaginary part of the numerator now. We'll collect the real part of the numerator and we'll collect the part of the denominator. Okay, So here what you are assuming that Z2 is not equal to 0. Note that. We will assume that Z2 is not equal to 0. That means what? One of the real part or imaginary part is not 0. Right? That means either x2 is not 0 or y2 is not 0. Okay. So now this will be what then? We'll collect the terms which do not contain I now. Okay. In the numerator. This is what? x1, x2 plus y1, y2 plus I times. So I will write the positive term first. Minus x1 y2 upon, now see I square is minus 1, so that means what? This is x2 square plus y2 square, so again I can, this is not 0, I can divide this, so I can write this as what? x1 x2 plus y1 y2 upon x2 square plus y2 square plus I times x2 y1 minus x1 y2 upon x2 square plus y2 square. Okay, so this is the basic concept of the fundamental operations on the complex number. How to take addition, how to take the subtraction, how to take the product of the complex number, how to take the division of the complex number. So for division we have to take the care of the denominator, right? So denominator should not be 0, and for addition, subtraction, multiplication, so if the complex number is 0, then 0 into anything is 0, then we are familiar with this one. Okay, so here what? There is no restriction on Z1, but there is a restriction on Z2 now. It is at the denominator. You know that the denominator is 0, then everything is undefined. Okay, so therefore we have to take the care of the denominator, so that complex number should not be 0. Okay, so and if the complex number, so obviously that what? So if there is the complex number at the denominator, and if you don't want the complex number at the denominator, just divide and multiply the conjugate of the denominator and simplify this, you will get a complex number. So that means what? Addition, subtraction, multiplication, division of complex number is complex number. Okay. So we'll take a problem. Verify that root 2 minus 1 minus I 1 minus root 2I is equal to minus twice I. Just we have to verify this. Okay, solution. We'll take this. Okay, we'll take this what? Root 2 minus 1 minus I 1 minus root 2I. So what we'll do? We have to open the bracket. We'll open the bracket. So this is what? Root 2 minus 1. Okay. Now here minus I there. We'll multiply by minus I now. So this is what? Minus I. So minus minus become plus. Minus minus become plus. Plus root 2 I square. Root 2 I square. But I square is minus 1. I square is minus 1. Minus I. So this is what? Minus root 2. So here what? This is I. This is I. This is I. Okay. So now here what? Root 2 get cancelled, and minus I minus twice I. So we are through. Next, we'll take next problem. Verify that 2 minus 3 minus 2 1 is equal to minus 1 8. Minus 1 8. Okay. Solution. 2 minus 3 minus 2 1 is equal to 2 minus 3I minus 2 plus I. Okay, and we will multiply this. Okay, first we will multiply by 2. This is minus 4 plus twice I. Then we will multiply by minus 3. Minus minus become plus 6I minus 3I square. Okay, so we have to take the care of I square. I square is minus 1. So this is what? Minus 4. This is what? Plus 6I. Plus 8I now. minus man become plus, so plus 3 now, plus 3. Okay, so now this is what minus 1 plus 3, minus 4 plus 3, this is minus 1 plus 8i, and this is what minus 1 8, minus 1 8. Okay, very simple, very simple. Next we'll take the next problem. Verify that 3 1 3 1 3 minus 1 1 by 5 1 by 10. This is product 2 1 2 1. Okay, so we'll do the product. We'll take the solution. 3 1 3 minus 1 1 by 5 plus 1 by 10, plus 1 by 10. Oh, not plus, comma 1 by 10. We'll write in the form of the complex number now, so that so this is what 3 minus I. This is what 1 by 5 plus 1 by 10 I. Okay, 1 by 10 I. First I will do the multiplication of this one now. Because what? So this is conjugate now, conjugate of each other. So this is what 9 minus I square. Okay, square of the first one minus the square of the second one. So we'll keep this as it is now, 1 by 10 I. Now this is what I square is minus 1, minus 1 become plus. So this is 10 1 by 5 plus 1 by 10 I. Very simple now here. And I will multiply by 10 now. This is what 2 plus I. And this is what 2 1. Okay, so we get the required thing. Okay, now this is very simple. So I hope that you understand this one. Complex number may be right in the order pair form. We'll take the next problem. Okay, show that real part of IZ is same as minus imaginary part of Z. Minus imaginary part of Z. Okay, solution. Let Z is equal to x plus iy. Let Z is equal to x plus iy. So therefore imaginary part of Z is equal to y now. Imaginary part of, I will write IZ. I want IZ. So I multiply by I now. IZ is equal to xi plus I square y. Plus I square y. So IZ is same as I square minus 1. So I can write minus I plus xi now. Okay. So real part of IZ is equal to minus y. But what is y? Y is the imaginary part of Z. So I can write this as what? Imaginary part of Z. Okay. So we have proved that real part of IZ is same as minus real part of IZ is same as this. Okay. So next problem, show that imaginary part of IZ is equal to real part of Z. Real part of Z. Okay, proof. Okay, solution. Let Z is equal to x plus iy. Okay, so we can write the real part of Z now easily. So we'll write real part of Z now. So real part of Z is x. Okay, now what you want? IZ you want. So we'll find IZ now. So IZ is equal to ix minus y now. I square is minus 1. Okay, so minus y. So this is what minus y plus ix. So this is IZ. What you want? Imaginary part of IZ. So imaginary part of IZ is the coefficient of I. What is the coefficient of I? Is x now. But what is x? X is same as real part of Z. Real part of Z. Real part of Z. Okay. So now see, very simple. Show that 1 plus Z square is same as 1 plus 2z plus z square for the complex number. Okay, solution 1 plus z square is same as what? 1 plus z into 1 plus z. Okay, so this is what? 1 plus z 1. So plus z square. So this is 1 plus twice z plus z square. Okay, so this is very simple. Next, verify that. Next example, verify that. Verify that. Verify that z is equal to 1 plus or minus I satisfies the equation z square minus twice z plus 2 is equal to 0. Okay, solution. What you have to prove? Z is equal to 1 plus or minus I. Okay, so case 1. Z is equal to 1 plus I. Okay, so we prove the z plus 1. So this is what? Z square minus twice z plus 2 is equal to 1 plus I square minus 2, 1 plus I plus 2. Okay, so we'll do this as usual now. So this is what? 1 plus twice I plus I square. Okay, so plus I square minus 2 minus twice I plus 2. Okay, so this twice I get cancelled, this 2 get cancelled. This is 1 minus 1, so this is 0. I square minus 1, so this is 0. For this, see, these are the similar, these are the equal but opposite terms. These are the equal but opposite terms, so get cancelled. Okay, so that means what? Z is equal to 1 plus I satisfy. Okay, so therefore z is equal to 1 plus I satisfy the given equation. Okay, now we'll write for z is equal to minus I. Now we'll write for minus I. So minus I. What we get here? Then minus I. This is plus I square. No problem for this one. So this will be then plus I. Then this will be what? Plus I. Then again, see, this is equal but opposite, they get cancelled. I square is minus 1, 1 minus 1 get cancelled. Okay, so therefore z is equal to 1 minus I satisfy the equation. Okay, so I hope that you understand this one. So you are familiar with this one. This is very simple problem, just by revising the complex number. Reduce each of the following to a real number. 1 plus 2I upon 3 minus 4I plus 2 minus I upon 5I. Second, 5I upon 1 minus I, 2 minus I, 3 minus I. And third one 1 minus I to the power 4. Get solution. So 1 plus twice I upon 3 minus 4I plus 2 minus I upon 5I. Okay. So now this is equal to 1 plus twice I upon 3 minus 4I into 3 plus 4I upon 3 plus 4I plus 2 minus I upon 5 as it is. This is minus I means minus 1 upon I is minus I. So we don't have to write anything now. Okay. So we'll do the multiplication for this one. This is what? 3 plus 4I, then 6I, then this is what? Plus 8I square. So minus 8. And these are the conjugate. Z bar is x square plus y square. Z means real part square plus imaginary part square. So 9 plus 16. Now this will what then? Minus, so plus minus I square. Okay. So minus twice I will write minus twice I here now. Okay. So minus I square minus 1. So 1 upon 5 now. 1 upon 5. Okay. So now this is what then? We'll do the simplification. This is what? Minus 5 real part plus 10I upon 25 plus 1 minus twice I upon 5. So again 5 get cancelled. So this is what? Minus 1 plus twice I upon 5. 1 minus twice I upon 5. Both the denominators are same. We'll take the addition of the numerator. It will be 0. Okay, so we'll check once again whether we are correct or not. 3 plus 4I, 6I, I square minus, okay, so this is also correct. 9 plus 16, this is correct. 1 upon I is minus I. So minus twice I minus. Oh, this is minus 1 plus, this is minus 1. Note that. This is minus. Okay. So minus plus, this is I square. So this is minus 1. Note that. This is minus 1. This is minus 1. Okay. So this will not 0 now. So then this 2I get cancelled now. So this is what? Minus 2 by 5. So this is minus 2 by 5. Minus 2 by 5. Okay. So you have to take the care now. This is minus I is what? This is plus I square. And this is minus 1. Okay. So we made a mistake here now. You have to take the care everywhere now. Okay. Next. We do for the second one now. 5I upon 1 minus I, 2 minus I, 3 minus I. So first what we will do, we will take the product of the denominator first. So 5I. Okay. So now this, we will do the product of the first one. Okay. So first the product of the first one is what? So 2 minus I minus twice I. This is what? Minus I square, note that. So this is plus 1. Plus 1. So 3 minus I now. So this is 5 upon. What is this then? This is 3 now. 3 minus 3I. 3 minus 3I. 3 minus I now. 3 minus 3I. Oh, this is what? This is minus 1. Minus 1. So this is what? 1 minus 3I. See, this is minus I is plus I square, but I square is minus 1, so this will be the minus 1. Okay, now we'll do the product of this one now. This is what? 5 upon 3 minus I. 3 minus I. Then we have to multiply by minus 3. We will take the care now. Minus 9I now. Minus 9I. So now minus become plus. Plus 3I square is minus 3. Is minus 3. So what will be this? Oh, numerator is 5I. Numerator is 5I. Okay. So 5I upon. So 3 get cancelled. So minus 10I. Minus 10I. So I get cancelled. So this is minus half. So it will be the minus half. Okay. Minus half. Now we do the last one. So 1 minus I raised to 4 now. So what we will do? 1 minus I square, 1 minus I square. Okay. So now we'll do for first one only. We'll keep 1 minus I square and then we'll write 1 minus I square as it is now. So 1 minus I square. So 1 minus twice I plus I square. So this is minus 1. Okay, so we'll write no problem. We'll write this 1. So 1 get cancelled. This is what? Minus twice I minus twice I. Minus twice I minus twice I. So 4I square. This will what? 4I square. So this is minus 4. This is minus 4. So I hope that we can do this one. Okay. So this is the basic concept of the complex numbers that we have seen. You are familiar with this. Okay. So now we'll stop here, and next part will be what? You know that in complex number there is modulus, argument, and so on. So next lecture we'll find the modulus of the complex number. So in the modulus of the complex number, so we'll get a practice for addition, multiplication, division of the complex number. So we'll solve number of problems in that also. So in the next part we will find the modulus of the complex number, okay, and the argument of the complex number. So now we'll stop.